This project is a simplification of the angel problem by John Conway. If you don't know what that is, it's basically there's two players, one tries to escape, one tries to trap the other one in. Um, but instead of being an infinite grid, this is on a finite grid. To make things a little bit more interesting, I decided that each agent should only get to see a small portion of the board. This also helps training go a lot faster, and given that I don't have a very beefy computer, makes it manageable for a 24-hour hackathon. So the angel only gets to see a 5 by 5 grid around itself, and in each square it gets to see whether or not there's a wall. But the devil gets to see a 7 by 7 grid. This gives it a little bit of an advantage, as when they're both even, it becomes very lopsided towards the angel. What's been going on in the background is a visual representation of this game, where the green square represents where the angel is, and all of the red squares represent the holes. Um, the ring around the outside is essentially the goal, or where the angel is trying to get to, and it wins the game if it can get to the yellow square, and it loses the game if it runs into a red square. The console in the bottom left shows the number of games played at this point, how long it took to get there, and then it runs 100 games, and it keeps track of how many times the mouse or the angel wins, and how many times the devil or the trapper wins. In the beginning, both players move very randomly, as you would expect, but as they start to play more and more games against each other, the mouse learns how to not just run into the walls, and the devil learns a little bit of how to make larger walls instead of doubling up in one direction. Fast forwarding now to 100,000 games, we'll notice that the angel has gotten much better and has actually been able to win more than a handful of games in our little sample size, winning 34 and losing 66. By 500,000 games, the mouse has learned pretty effectively how to move around the walls, and because of that, it now actually wins a majority of games, but it still doesn't have a 100% win rate. There are still times where the trapper is able to confuse it and sneak a victory. This project used Q-learning for both the devil and the angel, and everything was written from the ground up by me, instead of using a machine learning library like TensorFlow. The game can be split up into four main parts. First, there's the Q-learning algorithm and dual Q-learn. Then there's a class for each of the characters that controls how they read in the states from the board and how they choose their actions. Finally, there's a game controller, which actually controls the game itself. And then finally, we have display grid, which uses Pygame to show the nice representation of what's going on. These are the final Q tables for both players.